Wait, but that would mean the world would end. Because we would be dividing by 0. Dun dun dun!
And that's not possible. So, we need to find what we can get the denominator to put x thingy to equal to 0.
So, let's think about this the easy way, kids. What plus 1 equals 0? Well, my good friends, to do this, you would simply subtract the 1 from both sides. X would equal then -1. You can check this by plugging in. -1 plus 1 equals 0. Is that true, Amanda? Come on now, you can do this.
Oh gosh, I can do this.
Come on, we've been practicing. Come on.
1, and you can -1.
Yeah.
Am I on the right track?
Yeah, you are. Come on, you can do this.
And there's no fingers in yelling yes!
That's really loud.
It is possible.
So then that means you're... Amanda, tell a story.
Once upon a time, there was a little peanut. His name was Waffle. This.
Hold on. It's Celine! I'm videotaping Celine and Isabel. And Isabel! They're saying hi! Woohoo! Okay, back to math.
Okay. This was the original equation. This was the answer you got. And this is your restriction. That is it perfectly solved. Mind you, when finding restrictions, find it from the original denominator. Yes.
So Danielle, tell me, what happens when there is more than one at the bottom? What happens when there is more than one set of parenthetical majiggities at the bottom?
That just means more restrictions.
Oh my gosh!
My fingers just went numb. Let us show them an example of this.
Amanda is erasing the board with her head. It did not go very well.
Alright, put it off.
Okay, so this is the original problem, and this is it simplified, because it was factored out both ways. And then over here, you have this, and they're the same, so you cross them out. That didn't work. Cross. Cross. Okay, I have to... Oh, and this is the finished problem. It's hard to write upside down.
Bless you, Amanda.
I think you should be off. Is that it? Okay. So Danielle, what are the restrictions?
Wait, it's -3, right?
That's only half right.
Half right? What do you mean? Whoa!
Well, Danielle, this problem is only halfway right because, yes, -3 will definitely make the denominator 0, but you're also forgetting about this one right here. See, you need to show restrictions for every step that was included in the denominator.
Oh, I get it.
Yeah! So, because there's a -2 here, the other restriction would be 2. Oh my goodness, Danielle, you got it! Yeah! Yeah! Okay, so your final answer would be x cannot equal 2, or do you remember the one from the other one? Come on, Danielle, you can do this.
-3!
Ah! You did it, Danielle.
Yeah.
Or -3. Those are your restrictions. Bam! Now, can we please have any volunteers for this problem right here? And with this one, you just need to multiply it out, and then you do the same thing as before. So, any volunteers? Alright then, victims.
Dennis, Alex,
do it.
Pause for dramatic effect. And if you did solve this correctly, you would have gotten the answer x minus 6 over 3x parentheses x plus 3. And your restrictions would be x cannot equal negative 3, 0, or 1.
So we're on to the next section, 12.5. It's multiplying and dividing rational expressions. So first we're doing multiplying. So we start off with the problem 15x to the 4th over 9x times 12x to the 5th over 35x to the 3rd. Okay, so then what you have to do is you have to begin. Okay, so first we look for the common factors in the numerator and denominator of the product, and then you have to multiply the fractions times themselves times you have to multiply you have to multiply the fractions, multiply their numerators, and multiply their denominators. So you get this 15 times 12 times x to the 4th times x to the 5th over 9 times 35 times x to the 3rd. Okay. Then what you have to do is, so finding the common factor, which is going to be 4 times x to the 5th over 7. But then you're going to multiply that times 3 times 3 times 5 times x to the 4th. And then it will be the same thing on the bottom. They should be the same. Okay, so we have that. Okay, so then these two are going to cancel out since they're the same, and then you just have that. So then what you have to do is you have to multiply 4x to the 5th over 7th, which is what you have here, times 1, which equals 4x over 5th to the 7th, and that is your answer. Woo!
When you're dividing rational expressions, it can be a bit more challenging. So when it's a bit more challenging, who better to turn than Amanda? Well, yeah, you got this. But really, it's not that hard. Which you see, when dividing, you should just turn it into multiplication. So basically just flip it. So then you get this. Oh, I just erased some of it. So you get that. And then just solve it from there, and you end up with 175x over 36. And then you can party some more!
You should throw the emotional support sign away. Okay. Sorry, bad idea.
From now on, the idea of board throwing is definitely restricted. Thank you. Hunter.
Do not get up here.
Shit. Gracias.
This be restricted.
Yeah. Hoopla. Ciao. Zaijian.
I'm not gonna board throw this.
Adios.
Might hit somebody's back.
And that would be restricted. So, going into Dr. Yell's while he's not here
And taking stuff from him is definitely restricted.
But this is just a demonstration.
Keep that safe. Put it in your book.
Remember that, Joseph. The hidden note is underneath your desk.